In our Data Masterclass series, data leaders share their unique stories. We are happy to welcome Boyan Angelov, the data strategy leader at Exxeta and author of the books Elements of Data Strategy and Python, an R for the Modern Data Scientist. Our discussion focused on operationalizing data strategy. Let us welcome your host, Alex Borek.
Hello, my data friends. I have a huge pleasure today to introduce Boyan Angelov. He's a lead data strategist at Exxeta and has worked in a CTO role and several data science roles in the past, and is author of two very exciting books that we will talk about. One very technical one about programming languages in data, and the other one about data strategy. How cool is that? Really two different, very two different angles looking at data. Welcome to the show, Boyan.
Hello, Alex. Thanks for the invitation.
Great to have you. So let's get started by giving our audience a bit of a picture of who you are. Maybe you could describe a bit what you're doing today and the company you're working for.
Sure. I mean, you said it yourself, like lead data strategist, and data strategist, that's probably a very interesting role. And, sometimes you meet people and you always try to put a new person in the box, right? Are you a technical person? Are you a business person? It's very normal to try to do it. And with me, people often have an issue there because I'm really in the middle. So as a data strategist, my role is always to be between business and technology, to really try to translate business requirements, to help organizations move their data initiatives forward. And at Exxeta, my role is actually even much more than this. I'm responsible to build the whole data strategy function and have a data strategy team. And our job is really to make sure that any data initiatives we have we have a brilliant team of data scientists, data engineer, but my and the other data strategist role is really to make sure that there's value at the end. So I'm really focused on that one topic. But we are an international consultancy, mostly focused here on the German market, and we are around 1,000 people with 200 working students around, and we have been strategically more focused on delivery side, mostly on cloud, mobile, and now recently we started to really move into the data field, and this is where my role comes in.
Brilliant. My understanding, so I looked a bit at your company, and my understanding is that you guys really help traditional companies to become a bit more tech. Is that a fair statement?
That's a very fair statement.
With tech, I mean like the Berlin type of tech or the Silicon Valley type of software tech.
Definitely, right? And you said it, traditional companies, like companies which are either early or in the middle stage of their digital transformation, we really try to help them, to push them a bit forward. So I would say for our size, we're super innovative. We try to focus really on value. And again, we approach it from all angles, right? Not just data, but we're very focused on technology in general. So I know we'll talk about data strategy a lot today, but I also come from this also technical strategy, business strategy angle. So we try really to combine all of those, yeah.
And I think that is a very healthy thing to do, because in a lot of companies, it was managed too separately, the tech part, the software development part, and the data part. So I think it's a good approach to combine those things.
Yeah, definitely. It's not easy, right? But I think you can't. I always say like data strategy is a bit of like this Russian dolls you have, right? So you have like the business strategy, then you have the technical strategy, then you have the data strategy. So I mean, you really need to start with the business strategy. If you're not aligned there, it's pointless what we do in data, pretty much.
Very good. And we will talk a lot about data strategy because you just published your new book, Elements of Data Strategy. And we will talk about data strategy also from the background of your CTO experience, because this is where you needed to combine the data part and the tech and the product part, and also your data science experience. You worked in several data science roles in Berlin, in Amsterdam, internationally, in several locations. So we for sure will focus a lot on this today. However, I would like to start with your first book, because I think this is really, really exciting. So first book was published at O'Reilly, which is, of course, a very famous book publishing place. I think a lot of people would say as a as a technical author, this is the place to be if you want to publish books. And your book was about comparing two programming languages that are very close to the data community. And they are so close to the data community, but at the same time, they also create quite a bit of friction inside the data community, don't they? So we're talking here about Python and R, and your book was called, I think, Python and R for the modern data scientist. So tell us a bit about it.
Yeah, I mean, you said it yourself. I mean, when I was a data scientist, that's kind of the first part of my career. The big question, even for me, was because I come from the bioinformatics field, more like, and we did R. Actually, it was the first stuff I did with data. It's really focused on R, on metagenomic analysis, all of that. Then going into industry, people looked at me in a very funny way. So, you know R? Okay, so what do we do with that? So I had to learn Python just because the companies I worked at, they were typical Python shops, right? The other developers knew Python, so I had to learn that. And I was a bit frustrated because I thought, right, I mean, why do I know R so well? I love R. There's absolutely amazing features in that language. It became very modern in the recent years with the whole tidyverse topics. I mean, the data scientists, they'll know more about this. How can I use this going forward? And also at that point, at some point when I became a manager, people asked me, okay, now I start with data science. What should I learn? Should I learn R or Python? And this question is one of the most common ones. And this language war, it was called like this. So me and my co-author, we basically decided to end this language war because both of us, and me specifically more coming from the Python world after that, I realized it's amazing to know both. It's definitely an investment of time to know two programming languages very deeply, but it taught me a new way to think. It doubled the amount of open source I could use. If I can't solve a data science problem with one technology, I could just use the other one. And I had access to both communities. And I can tell you the R community is absolutely amazing as well, as much as the Python one. They're also very different. So that's why I wanted to write that book, basically to end the language war. And the initial idea there was, let's make a dictionary. And this is this would be as boring as it sounds, like to make a dictionary comparing two technologies one to one. So we quickly decided, yeah, let's not do that. Actually, we have an appendix which does that. But within the book, we try to show you that there's a tool which is best for the job, right? You shouldn't be so married to your technology. And I think these data leaders everywhere should realize at the end of the day, all of those things are just tools, right? I mean, they're not, they shouldn't be treated as dogma. You should use the best tool for the job. And that is the number one message I had in that first book. And it really teaches you a different way to think. Like the R syntax is very different from the one in Python. So by having this, you really had a different view on how to write code. So I definitely think that first book hopefully ended the language war, and I think you should know both languages. And of course, getting an O'Reilly book was super fun. And this animal, of course, we had the squid. People ask, how do O'Reilly choose the animals? There is some logic, right? If you look at the Data Mesh or other amazing books at O'Reilly, there is logic there. I mean, the logic with our squid was that it changes colors, right? As you change colors when you code in Python or R, right? You can be kind of like a chameleon. So that was the logic with the squid. And my kids love it, so that's another plus.
Feature. Perfect. So if you want to have an O'Reilly book with a squid, you need to get Python and R for the modern data scientist.
Correct.
And if you want to understand more deeply about these languages. But tell us, what are the main differences between Python and R? Syntactically, but maybe also, what would be the highlights you would say if to take away for people, who don't have time to read through the entire book?
Yeah. I think the most important differences, like the syntactic differences, are to be expected, right? You get used to them. There's a few strange things which now are being ported into Python a bit, like this pipe syntax, right? In R you have with the dplyr package, which is for data manipulation. You kind of order things as a sequence. So the input of one function the output of one function becomes the input of the next one. So it's a very strange way to make data pipelines. So in Unix, you have the pipe operator. So that's a very similar way. So that was made popular by an R package called dplyr. And I remember Python people really looked at this and said, wow, that's pretty cool. In 3 lines of code, I have this really brilliant data pipeline, which is very weird to read at first, but amazing also. the ggplot package, how do you construct data visualizations in a layer way, is also super weird. But to be honest, the big difference is where it is applied. And really, again, you'll see when we talk today, I always focus on the use cases. So if you work in finance, right, you have a lot to do with time series. There's amazing, really fancy statistical things which are just first available in R. Yeah. On the other side, yeah, you're trying to build a self-driving car, which is not an easy problem to do. Probably you're not going to do your computer vision work in R. I can tell you this with a high degree of certainty. So really focus on the use case, and then in bioinformatics and finance, you really get a lot of R. Otherwise, Python is really king.
That's my impression. So, I mean, I remember when I was working still at Volkswagen Group, that we quickly made the decision that actually Python is the way to go. I think out of two reasons. I think the first reason was simply because it was easier to deploy and integrate with more software, because usually you would need to integrate it with more software. You wanted to integrate it into a CI/CD pipeline. You wanted to build more software around it. And R is not a software language, not really. It's a scripting language. It's for statistics. It's a brilliant statistics framework.
100% correct. It's like it's made by statisticians for statisticians. But you know what? Now we see this full circle of technology going back. Now you have a lot of conversations about Rust and MLOps, and how Rust is a much more suitable and safe language than Python in some cases, and more performant. So, you know, in technology, once me and you, we have been around for a while, so you start to see those circles. So you have this kind of like more meta level view on technology, which I think is very healthy.
That's true. And maybe since you're mentioning Rust, because, you know, I think, you know, data leaders, this podcast is for data leaders mostly, but I think we need sometimes to make decisions around programming languages, and those are tough decisions. And, you know, I also noticed that Rust is a new kid on the block that you need to start watching carefully. Can you tell us something about it?
Well, my signals there, they're also very strong. So I have tried a few things in Rust, but obviously once you play with toy data, everything is simple. For me, the signals are more from what I see from the cloud providers. I think recently AWS started using Rust as kind of like a first-class citizen in their ecosystem. So now Rust is supported in a much more integrated way. And once Amazon does it, I think it's we should take note of this. And for me, that's a signal that we really, as data leaders, we really have to take that into account, right?
Well, I mean, the people who do the other things already and who are curious, I mean, a lot of software engineers and data engineers and ML engineers are very curious to try out new stuff. So I think that's a way to get people in there. But I guess the question is, you know, at Amazon, is that really something that is replacing data, like Python as a language for data science or for machine learning?
My signal there is a bit that in some specific contexts, specifically for MLOps, I have heard very competent people talk about this, right? And like once you see this, you kind of, and these are people who I know they're still coding very deeply. They make courses on this, they write books on this. I see this in big organizations. You know how like first Google does it, Amazon, and then everybody else. It's a strong indicator that this is going to happen. Whether that will replace Python, I don't think so. I think if something has been around for 10, 15 years, probably it's going to be around for 10, 15 years in the future, right? So yeah, I think definitely Python is here to stay, but I think Rust is very forward-looking. Another language is Julia, right? If you have heard about this, that's also interesting data science language. That has a different story, right? Exactly, it doesn't have the same support that Rust has. It has more specific use cases. So let's see about that one as well. So I'm really kind of keeping tabs on all of this. You have to, but yeah, it's hard to see right now.
So we have to watch it carefully.
Yeah.
All of us, and to decide when is the time, right time to start working with it, playing with it, because you don't want to be too early, but you also don't want to be too late, because that might mean that some of your talent might become dissatisfied at some point because you're not using the stuff that is really the most powerful out there. So I think it's a very tight balancing act.
Okay, correct. And technology, at the end, it's a tool. So have a very strong focus. That's why I became a data strategist, right? Because I understood that these technology decisions, they are very important, but you might get into a situation which I like to call, you dig a perfect hole in the wrong garden. So like I have seen super capable people building really amazing things, but then it's not connected to any valuable thing. On the other hand, I have seen very sloppy work, which was completely by accident, perfectly located on value, and it was very useful. I would always take the second one, right? as a business leader, yeah.
I agree. Well, since you already touched the topic of data strategy, what I really like about your perspective on data strategy is really that you say what you're really passionate about is how to operationalize a data strategy. You wrote a book recently, Elements of Data Strategy, and that's, I think, one of your big hypotheses or big things you argue for. How important it is to think through the implementation from the very beginning and not too late in the process of strategizing. Maybe you can take us through some of your main thoughts here.
I'll give you some background information on how I come to this, because you see my opinions, how they were shaped by my life. So I came to this, I got the title data strategist without anybody telling me what to do, right? So you get this title, you get basically the goal, make sure the data initiatives work and deliver value, and then off you go. See you at the end of the project. So that was really what I got. So with this situation in mind, so I was already quite senior, so already knew quite a few things, but still I was wondering, so what do I do? So first I asked the other data strategists, guys, so what do we do actually? What's the job? And I did get some things. I heard a few things. I heard current state analysis, gap analysis, value stream mapping. I think, okay, cool. These are nice, but how does this fit together? Like, really, what do I do day to day? I managed to figure this out eventually on my own and with a lot of help from my colleagues and from clients, but I did it the hard way. Because also at that point, I had a look at data strategies, right? I had a look at government level data strategies, like big PDFs, right? We have one in Germany, which is nice. I mean, there's conflicting opinions there, but big documents I saw from big companies. I saw our data strategies before. I read them and I thought, wow, okay, but it sounded very competent. It sounded very thought through, but I didn't know what do we do with that, right? I have this big slide deck, but I had no clue. I really put myself in the shoes of a customer which bought these things, and I thought, yeah, well, I mean, what did you buy? Because then the customers would call you and say, yeah, we bought a data strategy, we still don't know what to do. I still get this to this day, questions like this, the companies who have a data strategy, which was not specific enough. So in that sense, I was a bit of a rebel because that pissed me off. That didn't make any sense to me to have like a big PDF deck. I really disliked that. And I always thought that data strategy is absolutely pointless if there's no value. I mean, in general, data science as well, but with data strategy, it becomes even more vague sometimes, more complex. It's much more easy to be imprecise in what you do. And this is why I sat down and put my learnings into this book, right? So I started writing this book very quickly after the first one, just because the pain of writing this was much less than the pain of not writing this. I had the feeling that I have this perspective and I know other data strategists who have the same questions I did, the same frustration with static slide decks I did. So I try to make data strategy in a very interactive way, right? So it should be the opposite of a static slide deck. But this is kind of the motivating factor. And to this day, this really influences my thinking about strategy.
So maybe let's take a step back here. When you start to write the book and when you published the book, you were actually working on data strategies with other companies. How did you approach that? Like if you from that sort of angle, from that sort of, I would say it's almost like a belief system. How did you approach data strategy?
That's, I think, the best way to do it, right? I mean, I immediately got this feedback loop. And exactly one interesting thing which happened there once, like I did one data strategy for an organization, which I later joined as a CTO, right? Which then I had to implement a data strategy, which is a totally different thing I needed to do. But I always had this loop because the clients at that point, and I think this is where we are in Germany right now, that organizations, first they realized you can't just put some data scientists and expect magic to happen, right? They had to get data engineers. Yeah, you do need like to work on the data. You need to prepare it for the data scientists. So all that was fine. And now I think organizations start to realize, well, that's also not enough. We do need something else. And I argue that you do need data strategists, whether they have that title or they're analytics translators, data program owners, data product owners. That's besides the point, but you need planning around the activities to make sure there is value. So me working with the customers, I saw this immediately. Anytime I mentioned the word data strategy, they almost got bad flashbacks, because they didn't care about static documents themselves. They just asked me, I give you a concrete example. One organization said our data team doesn't perform well. And you might think, well, what does that have to do with data strategy? I mean, it has everything to do with data strategy because then if that doesn't work, nothing works. And I wouldn't prepare for them a strategy on how to make their team work well. That's a weird thing to do, a data strategy in that sense. What I went there, I implemented some ideas which I call the sources of waste from lean manufacturing, some ideas where you look at things like how frequently people deploy, how reproducible the work of the data people is. Looking at really operational things like that as a data strategist. So I really always had to be very close to the metal, as you say. And this is probably the hardest thing for this job, is to operate very high level. And the same day you go very low level, right? And I always had to do it from day one, I would say. I had to make very big, large roadmaps, which are not sometimes very specific, but still I had to monitor how this works operationally, right? So I really had to look at very concrete things. So I think that was more of a feature than a bug, that I worked with clients as I was writing the book, that I think helped me be much more focused on value, I would say. Try not to be too academic, which is always a danger.
It sounds almost like a contradiction. At one hand, you're saying data strategy is pointless. It's creating PDFs and PowerPoint decks that are too vague, that are nobody implements them. And I mean, I'm exaggerating, but that's what I hear, and at the same time, you're saying the most important thing right now for companies is to hire data strategists and do data strategy. So
let me clarify.
Please clarify that.
The old data strategy is pointless. The old data strategy, the static way of doing data strategy, where you hire management consultants which have little understanding of your day-to-day operations without enough technical due diligence, a data strategy which is inflexible, which is 5 years in advance, that is mostly pointless, right? Especially with the current climate, how quickly things change. I think to continue having competitive advantage, you need to have a flexible data strategy. And this is the whole strat ops topic, right? Which is, like people talk about ML ops, data ops. Yeah, we do need one more. We need strat ops, like to make a strategy which adjusts itself, right? So you can't make a perfect, imagine you build a perfect cathedral, right? That's a very brittle thing to do. You spend so much time making a perfect plan, but it faces reality, And instead of making a perfect plan, make a decent one and invest time to readjust once you implement things. This was one of the most painful and important learnings to me. This is why I'm very much against a static data strategy, but a dynamic one is the most important thing you can do, I think, as a business.
So how do you approach a dynamic data strategy?
Maybe I can talk about my experience, how I failed doing this. So I think I always like to talk about my failures because I think you learn a lot from them. And those are painful lessons you can just take forward in your career. So I became a CTO at a company where I did a data strategy for. And my data strategy was clean, right? It was clean. It was very standard. I took a lot of inspiration from my book still wasn't ready. I wasn't there yet. but I took a lot of inspiration from business strategy, and I managed to do in my opinion, and my colleagues hopefully, and the client obviously because they hired me, a competent data strategy.
So what was part of that data strategy? I mean, what were the key elements of that data strategy?
So basically very similar to what I would still do, right? But I didn't de-risk it. It was very focused on use cases. It was focused on the operating model. There was a due diligence, right? There was measuring metrics there. So the standard things we can talk about later. It assumed one thing very important. It assumed that the use cases are end all and be all, right? Because what I learned then when I started to be a CTO and I had to implement this data strategy, basically use a data strategy, we changed the use cases a little bit, right? So instead of, we had two use cases. One was mostly focused on personality, right? So kind of like famous people, whether they get about the yellow press to help them defend against scandals, like things like this, finding data on the internet to support this. And the other use case was most focused on copywriter photographers. To be honest, they sound like from outside very similar, and they are very similar. The big problem is the sources of data was totally different. And this is that when I learned something I call the influence cascade. So basically the new use case, which we had to do, the data had to be scraped instead of bought. So suddenly my teams, they had to maintain a scraper. The data quality was bad. It wasn't reliable. We do need a lot of manual reworking of the data. It was too much data as well. So my clean cut use cases, which relied on clean and in-time data, all of them broke basically. We couldn't deliver with the same time that we planned. It's not like we needed to throw away the data strategy. We still use that. But it taught me a lesson that once you decide for use cases, you really have to freeze them, right? Because any small change in the use case and in the data has really dramatic consequences downstream. For example, let's say from an external perspective, you might think if we do churn modeling and we have like text data and tabular data, well, what's the big deal? Well, there's a lot of big deals there because for text data, suddenly you have much more of it. Suddenly you need NLP people. Suddenly you need to deploy it in a different way. The whole pipeline changes while the use case is the same. So this is a very painful lesson to me. This is why I always, when I do data strategy, I spend a lot of time on due diligence, and really the use cases have to be we have to make sure they're feasible and the data is there, and no assumptions on that level. Otherwise, everything goes outside of plan very quickly.
No, but this still happens. Like, you cannot avoid things changing. I mean, you said, yeah, it's good to keep use cases stable. Yes.
Yeah. That's kind of that. I think I'm a bit damaged from the role, because being a CTO, you kind of, at least one person has to be very and I think as a data leader in general, if you're a CDO as well. So I was a CTO, and that role, you have also like the public responsibility to bear the flag of clean data, of like the holy grail. You have to be the one who is championing the use cases. Somebody has to be, or at least the peer perfect. Somebody has to have a very solid plan, and somebody has to push the organization towards perfection, right? Of course, I always know reality is messy. But if you're a leader, you really have to be present yourself in that way and inspire people around you and focus more on the positives, right? With other data leaders, I do like to talk about the negatives and the real world problems of the job. But towards the organization, I really had to look at the gold standard, right, of how we do things.
Right. So what you're saying is basically you cannot adjust all the time because your capabilities need to be adjusted. So you need to, it's a very careful trade-off when you make changes in the use case.
Be careful portfolio. What you say, right? If you're a chief data officer, chief technology officer, anything you say, people immediately start to think, well, we have to do that, right? If, for example, you're in a meeting at the chief data officer and say, wow, ChatGPT looks amazing, I wonder how it can help us. I can tell you that you have your data people running around, working on use cases, and 3 months later they have done something. That might be a good idea, but maybe not if you want to conserve resources. So be very careful.
Well, let's go back to your second book, The Elements of Data Strategy. What are the elements of data strategy actually then?
Yeah, I mean, another thing on that book, you have to understand, like I talked to the interviews in the book, they shaped it a lot, right? So I got a lot of feedback on those elements. So the bigger foundation of the elements was from me. That's the first thing I did before I wrote the book, is to just drew the elements of data strategy. Mm-hmm. And the first thing, the data leaders I interviewed, and among them Tom Davenport, who is one of the people who invented the term data strategy like 30 years ago. And he told me, the first element should be alignment with business, Yeah. And I was thinking, well, isn't that obvious? And he and also others said, no, it's not obvious. And literally, that's the first element, is aligning with the business strategy. Now, to be very specific here, there is a very cool method called KPI value trees, right? Where you have like a business goal. Let's say the goal of the business is to sell t-shirts, and to sell more t-shirts in Southeastern Europe, let's say. That's kind of like a traditional goal. How do you align to that, right? You can't just say, we make data-driven decisions for our business. That's a bit too vague, What you need to do is, for example, you can say, to sell more t-shirts in Southeastern Europe, first we can segment the market. Maybe we can do some customer segmentation. Maybe we can create a churn model, right? Which kind of indirectly leads to the same goal. So this kind of construction of measurable things which align with the goal, this is the first thing you need to do. And if you don't understand the business, you don't have you shouldn't be there, almost, I would say. And it's easy to underestimate. What do I mean by understanding the business? I always underestimated this, being a technical guy. It took me a while to learn. You really have to learn how a business works from A to Z. So being a CTO, I had to do it, and it's a very valuable experience to learn how to do business. So that's the first element, align with the business strategy. And the whole first phase of data strategy contains several other elements, but all of those are called due diligence, which are borrowed from other industries like auditing and everything else. Because you do need to prepare. Like, you can't go to a company, let's say now I go to a company I've never seen before in industry, I have no clue about, and I can start doing a data strategy. That's the last thing you should do. You should really prepare. And every company is different, every data strategy is different. And in the due diligence part, you are focused on having a look at the use cases which are already there, architecture, the data quality, who is working where. And the final element there is the so-called gap analysis. Let's take an example. Let's say you're a Polish clothing manufacturer, right? And you want to do a data strategy in that context. Well, you have aligned with the business goals, you construct your KPI trees, you had a look at the data and everything. Well, the last thing you need to do is the gap. Yeah, so this company, you have to ask them, and that's not a nice conversation sometimes, where do you want to go? And of course, everybody will say, we want to be on Amazon level or whatever great tech company in the field. Well, that doesn't work that way. You have to find the right level, and there's some market research there going on. And this really helps you kind of position. You always talk about having competitive advantage in data. This is where you see it. And the client starts to think, well, data can help me, move to be the best Polish clothing manufacturer, which is the most digital one. And that's very cool and that's very inspiring. So that's the last thing you do in the first phase. But a lot of preparation before you go into the design. But these are kind of the elements at the beginning you have to do.
What I got from the elements is, so you come and you look at the alignment with the business strategy and alignment with the business. You look at certain metrics and sort of, you could say North Stars, for what you want to do to make anything that you state as goals more concrete. And then you build a very solid, a very inspirational aspiration on top of that. That is realistic, though, in terms of where you are and in terms of where you can go. Is that right?
Yeah, that's right. One thing I forgot to mention is a very concrete deliverable you see from all consultancies around the world is data maturity assessment. So you have those everywhere. So that's part of that.
To benchmark
the benchmark. One thing about benchmarking, one other big mistake. If you don't set up your goals correctly at the beginning, then let's say you just say, okay, we aligned with the business strategy, but why should we measure things? It's obvious it's going to be fruitful. You could assume that. And you go there, make the strategy, then you have the data scientists making the use cases, engineers deploying them, and then you're done. And then what has happened to me in my career is people ask you, well, now that you did the job, you deploy your churn models, how do we know if it's useful, right? That's a very painful lesson, because then you don't know what to say, right? You say, oh, wow, now we should have collected that data before and after, right? So that's a, typical mistake. You really need to prove numerically. It's very hard, to be honest. I fight a lot with like data people in general about this, but you have to have some kind of a direction. It doesn't need to be super quantitative. Do we have a direction? Yeah, we deploy the churn models. Do we really sell more t-shirts in Southeastern Europe or not? You don't need to do some kind of t-tests or whatever, but roughly, does it happen or not? You have to be able to do it. Honestly, it's very hard, but.
So what is the hard thing about quantifying value of data products or products that are based on data?
Number one, it's indirect, I would say, the contributions, right? Because rarely people do what we just discussed. Rarely you have these aligned KPIs. If you had aligned KPIs, you can measure this. Let's say your churn model, you can really measure statistically how you contribute. And financially, you can, honestly, you can always, most data products, they help save time. If nothing else works, you can always try to estimate time saved per qualified labor, right? People looking at the dashboard, instead of digging through Excel files here and there, you can kind of estimate this and have a numerical value. But the hard problem is it's buried somewhere indirectly. I'll give you the example of a data platform. In general data engineering work, it is an enabler, right? Like building like a system where data scientists can work productively in an organization. Let's say like the data engineering team has built like nice sandbox environments which are easily configured, easily provisioned, easily destroyed. And the data scientists suddenly can work very well there. Well, the data engineers, how do they measure this, like how impactful this is? So it's a bit qualitative. They can say our data scientists, they do great work. But the problem is if the data scientists are doing stupid use cases, all of this doesn't matter, So it's kind of this indirect pyramid of enablers, which is called the data science hierarchy of needs. But unless this loop is closed, you can't measure. You have to, that's why it's good to deploy things very fast, because you can immediately measure things. And then everybody along this value chain can say, we have contributed to the selling of t-shirts in that way and that way, right?
You basically need to consider the entire value chain from data science to data engineering to data platform.
All of this, 100%, from the beginning, yeah? And this is something I call close the loop.
The data scientists might say, it's only because of me that we're making less churn. And then the data engineers say, and the data platform people say, hey, but what about us? Don't you need us? Yeah, we need you, but you're not creating the value. It's us creating the value.
No, that's a hard topic. I do think this is a topic of culture where you do internally in the companies. Let's say you're a chief data officer. It's your job to explain to the marketing people, what do the data engineers what are they doing? It's your job to explain that and teach that. And that's not easy, right? Because to them, they look like, well, the data scientists are doing the models. What are those guys doing? It's like an upskilling topic. You literally have to explain a lot. That's a big part of that job, I would say. Big part.
Great. So let's look at the next phase. After due diligence, we have the design phase. Can you tell us what you do in the design phase of a data strategy?
So the design phase is where you start to show productivity. This is something I didn't touch in the whole last part, which normally would take several months. I would say weeks to 6 months, maybe depends on the project. In due diligence, there's no artifact of data strategies work which is like productive. You have these data dictionaries, you have architecture diagrams, entity relationship diagrams. You have a bunch of stuff, documentation basically, and people start to ask you, so what's up, right? Where are the results of your work? And unfortunately, there won't be any. You have prepared, and now you do the making the data strategy, but you can do it in an informed way. You're not going to reinvent the wheel. You understand the business. You have sold the business, right? You understand the context, and then you can design the data strategy. And here the things are, this is a bit traditional. I think now it's quite established approach here, starting with the use cases. The typical data ideation workshops where you take the right people from different parts of the business, you look at possible use cases. That's why the results, remember, from the gap analysis here. Now you can take the Amazon for t-shirts and then go to the Polish company and tell them, yeah, they do this, they do whatever advanced analytics, computer vision stuff. Yeah, and this gives an input to the use case ideation part. So you have a lot of ideas. That's easy to get a lot of ideas, but now the hard part here comes, which I see also a lot of mistakes, is the technical feasibility. You have the use cases, but unless you have done your data dictionary, diagrams, all those boring artifacts from the due diligence, you can't estimate what is feasible and what not. But fortunately for you as a data strategist, you have done this work, so now you can say, well, we don't have the data here. We do have the data there, right? And you can immediately say, well, that's possible, that's not possible, right? We need these people, that people, right? So you can quickly do a feasibility round, and then you can prioritize. And the prioritization part also should be straightforward because you have aligned with the business KPIs. So you can kind of look at, does the use case of whatever customer segmentation help with more selling of t-shirts in Poland, right? Or not? How much does that help? And then you can do typical consulting 2x2 matrices. That's this ideate, feasibility, prioritize, this triad of things. That's what you do, right? But that's the use case part. The other interesting things here, which are also quite standard, I would say, operating model. Also, how do you set up basically the teams, right? You have distributed, you do a center of excellence. This connects with the...
which kind of roles, where do they sit, how do they work together?
Yeah, this is enough literature on this, to be honest. It's like not a solved problem, but there's really amazing work there. Also connect to the data governance topic, which is also very big, the data mesh ideas, team topologies, all of this stuff shouldn't be underestimated, but there's very good, understanding now what you should do there. Now, one thing you do here, though, which is again technical, is target architecture and technology. Yeah, and that's, you have the current state architecture from the due diligence, and now you need to, and you have your use cases. Remember my mistake as a CTO. Now I have the use cases, I know about the data, I know about the architecture. Now I can safely have a target architecture. Knowing all of this, I can safely make a decision for my cloud provider maybe as well. Because now I know, this weird data governance thing that I need for this use case. Maybe I have many customers that need very federated access to the data, maybe distributed access to the data. Maybe I should use Azure because they have a fancy new tool called Purview, which scans automatically your data lake, and you can do data governance by clicking around. So by knowing all of this, you can make such technology decisions there, right? And that's the last element. And of course, at the end, you do need a roadmap and a budget, right? How much things will cost and all of that,
So, but maybe going back to the operating model, what is important? You said it's a very well described problem, but what did you find out, from reading and from practice?
Let's take a biological example here. Let's imagine you have a lake, right? And you have one type of fish swimming in this lake. And there's some kind of disease, right? You have one species of fish and you have one disease, and all of those fish are gonna die because of that disease. But if you have several different types of fish, right? Some of them are gonna survive. So this diversity in skills makes you much more flexible. And remember what I said, reality is very messy, and you do have to adjust. So in that sense, I always like to think about very small teams, which are very... have and a lot of data mesh ideas there, right? So you have a data engineer, data scientist, data strategist, right? You do need those, all of those skills need to be present in many people, right? You're gonna have people like data architects who know some strategy even, like they don't need to be totally separate, but you really need this diversity in your teams. So even if the operating model fits a lot, let's say you do a center of excellence, if it's a very homogeneous team, you have like 25 data scientists, you have one architect and two data engineers, one of them is an intern, that doesn't make a lot of sense, right? So, and don't underestimate the data strategist, right? Like this is one thing which I haven't seen yet. People forget that you do need a technical product owner, this type of roles. You do need this person.
I fully agree with you. If I know one recipe for disaster or failure, it's really like hiring only one type of role and putting that like 20, 30, 100 of people of the same role into one center. I think that's if the only way to make that work is if you have another center and another center next to it and you mix up these teams virtually. Maybe that's the only way how you create value out of it. But you know, it's like in nature, like you need diversity.
And cultures and like what kind of environment this is, depends on the use case. Sometimes you have data strategies which are more incremental. You have something like organizations which already are quite competent. We do have those, right? I mean, I know I talk a lot about how we're not far away in Germany, but there are some organizations which have already good data products, So there, obviously, you can take more risks, right? You can, I think, then be a bit more homogeneous in your teams, I think, because it's incremental. So it depends.
Great. So we talked about the diligence phase of data strategy. We also talked about the design phase of data strategy. Now, I remember you told me that it's all worth nothing if you cannot deliver. So how do you deliver data strategy?
Yeah, and that's this whole part of the book. I was thinking, should I add it to the book or not? But again, because I already wrote the first two parts, and I was thinking, I told people how to do data strategy is done. But then I kind of contradict myself, the philosophy that it doesn't matter if you don't deliver. So I said, okay, let me figure this out. And I'll be honest with you, this is something which I'm still figuring out because that's the hardest part, when the wheels hit the road. My views there are focused on several things. Again, you see, I try to break down the elements in very concrete things. So for delivery, you have portfolio management, you have data ops, and you have impact assessment. So from those three things, I'll start with the first and the last one, and let's leave data ops on the side because there's a lot of different views on what data ops means. I'll tell mine in a second. But portfolio management, this is something. Imagine what happens now. You have done the data strategy, and normally in bigger companies you have 4 use cases parallel, right? There's a lot of work, right? For startups they're much less, but normally it's a lot of people who start to work. And you have to steer those in a smart way because most of those things will fail. And I mentioned StratOps, a lot of those data initiatives, they will fail. I mean, that's the reality. Some of those things you can't predict. This is why you have to do several at a time. But managing this and monitoring how those things work, and you have to sell those topics internally. Because remember, a big organization, you have a nice use case, and it's even, you can measure the impact, it's great. But if people within the organization who have to use this, the users, they simply don't know about this, again, it's pointless. Again, you have a marketing problem here too. I mean, I talk about internal data science use cases, obviously the customers too, right? Somebody has to sell the data products to the customers. So somebody has to make demos, somebody has to find other use cases, you add more features, right? You integrate into existing products. This is portfolio management. And there's a lot of ideas there. Impact assessment basically should take the metrics we mentioned, right? Like your churn model metrics, how do they combine? How do they contribute to the big business KPIs? But let me talk finally about the last one, because I think that's the most weird idea I have there is the data ops one. Basically, it's agile and lean. And I know I'll get a lot of flack for this. I know a lot of people disagree with me here. I asked everybody, so how do you project manage data work? Nobody ever told me that 100% agile is a great idea. So nobody said this. But a few people said you just can't do agile. But like most people agree that you do need a soft version of agile also, right? Like you do need to be a bit flexible on how you do things. For example, as compared to a traditional software project, those data science use cases, you can't ask people to estimate certain things, right? Because many things you learn only when you do them, right? You might think the data looks good, I should be able to make a good model, but then you realize that's not the case for whatever reason. Maybe the label wasn't strong enough, maybe the human annotators, they made a mistake, and then you have to start from scratch. And so you can't estimate data science project sprints very easily because of such problems, right? So you do need like a soft agile.
And I couldn't agree more. I think this is the biggest difference to conventional software products. When you're talking about machine learning or AI-based products, it's really hard to estimate and to know upfront, does it work? How long will it take? What is needed to make it successful? It's much harder than the normal software planning process. And this is where I found some of the product managers that don't come from machine learning really struggle in doing proper product management, because they or understanding the different needs.
Yeah, and I agree with you 100%. On the other side, we can borrow a lot of things from software, which I did, right? We should. It's still software at the end of the day.
Yes.
But the operations of this thing are hard. So the other methodology called Lean, and this will be one of my book recommendations at the end, the Lean manufacturing idea. So I always focus in my career. Sometimes it's not easy to say what's a great thing to do. It's a bit vague. How do you say, how do we manage a perfect data science team? How do we do a great job doing this? An easier question is, how do we mess it up? What should we do that data scientists have a terrible time implementing the use case? And to be honest, once you think in that way, you get very concrete things. And I like that a lot. I really like this a lot. So basically, I can tell you, give them no access, make them wait, don't give them nice laptops. It even starts there. Ask them to code in weird technologies. Don't think about integration points.
Give them data that they cannot understand.
Yeah, don't tell them what it is. They're very concrete data science things, which are these are more focused on data scientists, really waiting for access, having bad data. You really try to, if you avoid those things as you manage those portfolio of use cases in delivery, you will be already in a good spot, I would say. So this negative thing, I try to focus in that way. So the Lean part of my book is really focused on that one, on really looking at the negatives and removing the inefficiencies.
So removing the frictions, that's... Mm-hmm.
That's it. And this, to be honest, there's no strategy there. It's basically, honestly, any team will tell you immediately what the problems are. Yeah. And these are normally easy to solve, to be honest, right? I mean...
Yeah. And if you remove all frictions, you can deliver the product.
Yeah.
Very easy.
Very easy.
Great. Boyan, you have been working actually with a lot of startups, but you also have been working with quite large companies. Where do you see the differences when it comes to data strategy?
That's a very good question. So small companies, startups, they have a lot of agility, but no focus. Big companies have a lot of focus and no agility. Whether that's a bug or a feature is up there to say, right? The problem, the difference, I would say the big difference is really in how quickly you can do things and if you have the right mandate. And to be honest, in startups, if you achieve technology officer like I was, it's very easy to say what needs to be done and plan things. So you quickly can do things. The problem there is that the constraints you have from the market are big because normally your startup doesn't have very few startups are profitable, right? Early on, especially. Like normally you operate in a circus, like you don't know where the money comes, you don't know which use cases are useful. You don't have resources, basically. You operate in a very hungry environment.
Uncertain environment.
Uncertain, you don't have resources, you don't know which use cases work and your business model doesn't work and you don't have time. And that's hard in a different way. I think then you have to make a more smaller data strategy. You have to focus on doing things faster and making sure you pay for your use case very early. I would say this is still similar to the situation of a big company, but there we have a lot of problems with rigidity, with upskilling. But on the plus side, they have normally a business model which works and normally the resources to do things. For both of those use cases, I'll be honest with you, from the fundamental things are really the same. At the end of the day, can you get value from data or can't you? And the earlier you show it, the better. So to be honest, I have done both and it's the fundamental differences are not that big that you might think. if you really focus on the fundamental level, right? The data strategies do look different, but at the end of the day, is there value from the data work or no, right? And can you deliver this fast enough? At the end, it's capitalism, right?
But it's getting definitely more complex as you are in a larger company.
Yeah, complex in some ways. Definitely more people, more like different teams,
more politics,
more operational inefficiencies you have, right? So it is a bit more complex, I would say, yeah. But the complexity is in a different place because you kind of know the use cases, or at a startup, you really have to know the use cases. You know, you don't have the same risk. The risk distribution is a bit different, you know. So I think that makes it different.
What kind of advice would you give for data leaders that look to build high-performing data teams? What's your biggest learning there?
Make them understand the business, you know. This is something which I always heard, like Amadeus Tunis, who is like in my book also. He's in the US, and he told me that one of the best advice is telling your data people to read newspapers, you know, and learn about businesses. Like, how do you sell socks? How do you sell cucumbers? How do those business models work, right? Traditional business models, you know. And high-performing data teams, I think it's much more important for the teams who normally, my philosophical assumption about people is they're motivated to work. I honestly believe that, right? My teams, when they come to me, they want actually to work. You spend your time at work. So my job is kind of like to motivate them, to make sure that they work on the right things, they understand the value, right? To point them in the right direction, I think. Everybody wants to feel they contribute to something, but this contribution relies on their business understanding, because you can tell them, yes, we because of you guys, we sell more socks now, but they have to be impressed by this. They have to understand that their work contributes to that immediately. I think this feedback loop will help you have high-performing teams.
And Boyan, you worked as a CTO and as a data leader and as a data scientist. So what do you think about the CTO CDO relationship? You know, I guess in the company that you worked as CTO, you didn't have a CDO. You were doing both at the same time. Yeah. Do you recommend that setup, to scrap the CDO and have simply a CTO that gets data?
No, I don't think it's possible, right? I do think a CDO is a very important role. Like, data is just very different, you know. Like it's everything about it is fundamentally different. The CTO role is relatively established, right? It's relatively clear what the job description is. But a CTO to understand data problems, they have to think in a different way. That's why you do need two roles. And this is a big challenge I always have, is like operating on different levels, right? So how I manage my software teams is very different how I manage my data teams, right? And this is hard for...
Why is it different?
The complexity, the amount of risk, the amount of explanation I need to do to the CEO, to the CPO, to the CIO, to the all people I need. If I have a data team, because normally those are expensive, everybody will ask me many more questions. So I'll spend much more time upskilling my other people and selling and negotiating and trying to get value, explaining what AI is. And as a CTO, this is something, you know, normally it's a more operational role, right? A CTO is a more of a visionary role, where you kind of focus on the North Star. It's a new frontier. There's many, it's kind of on the edge of innovation and competitive advantage. It's very hard to find an innovator and an executioner, in a way, like somebody who executes and is operationally very strong, but at the same time innovative. Rarely is the same person, right? So this is why I think CTO is more like operational, like getting things done, while a chief data and AI officer, you do need somebody who is more visionary and focused on evangelism a bit more. I don't like that word, but that's kind of the job. That's why I think for the foreseeable future, we're going to have the two roles, I think.
Thank you. That's a very, very interesting viewpoint. And it gives me hope for the CDO role, actually, because I think that's a big question mark at the moment. You know, will these two roles be still existing by themselves? I noticed some CDOs moving into CTO roles. I also noticed some CTO roles taking over responsibilities of the CDO role recently. So I definitely saw that those roles There are some, companies at least that stronger merge those roles. But I also see what you can observe in terms of almost a conflict in interest. You need two roles to have those two hats, because those are really two hats, two viewpoints on the business. Because there is a data layer that is above the tech layer that needs more attention.
You do need those roles. You do need to specify them a bit more. And those people have to have different skills, right? As I mentioned, like your CDO has to be very good at negotiation, right? Very good at, very up on the edge of what's in the market, right? Normally a CTO, at a bigger company, you are more like making sure things are operational. Right. Yeah, things move, but you don't try to take risks, right? This is kind of the opposite. A CTO, that's the last thing you want to do is take risks. But guess what? For data and AI, that's the first things you have to do is take risks. And
managing risk is the job of the CDO. It's correct. It's all day managing and communicating around risk.
Yeah.
Wonderful. So I know you talked about AI, and I know you're very passionate about thinking of how to infuse AI into products, into software products, or to think of AI as a product. Can you tell me a bit, your philosophy here or your viewpoint?
The philosophy here is, again, that's why I actually do like to be a CTO, because you get to integrate the AI into something else. And when we say AI, let's be direct, right? We have some machine learning endpoint somewhere, yeah? To make it very specific, we have some churn model, there's an endpoint on Azure, and that's it. The first thing that you need to pay attention to is what happens to this endpoint. And this is the product thinking, what happens to this endpoint? Sure, we touched about this a bit when we mentioned you have to measure things before deploying and after deploying. So you can have like a comparison after deploying some product. What does the business go further or not? But these integration points, this endpoint will integrate into an Excel file, it will integrate into another internal system, it will integrate into a dashboard, into a graphical user interface. But this type of thinking is normally the realm of another person, of a product person, right? Like user interface people, in the case of a human person there, or it might be a process thing. And I can tell you, it's easy to underestimate processes. And there's like these people who do a lot of Signavio and, Celonis and this type of stuff. I can tell you, like, this is very hard. In big companies where you have big, let's say, invoicing processes, right? In a big company, to make an invoice in a big company, a bank, let's say, or whatever, it's like, wow, it takes a long way. A lot of things are happening in different places. So when I talk about data and AI products, you have to have the product thinking. How do things integrate? Yeah, how is my think part of something else? And as a data strategist or a data product owner, this is a big part of your role. And that's a very concrete experience that you have to learn. Your endpoint is pointless, as I said, if it doesn't go anywhere. And that's very hard. I'll give you examples. You make your nice endpoint and your latency of the prediction is 3 seconds. And your team thinks, wow, great, we did such a great job with this crazy model, we trained it and it's online training and it's so fast. And then you go to the product person and you tell them this and they're like, are you serious that now our users have to look at the spinning wheel for 3 seconds? And then you have a really big problem, right? Because this is not a model problem, but more infrastructural, which means you don't have the right people normally who know this weird knowledge, how to index databases or, how do you optimize queries and strange things to get from 3 seconds to 1 second. So this is a lack of product thinking. And this is a whole field that people should learn. And my experience is integrating early, understanding the process. Like, it's just not enough to work in isolation, right? It just doesn't work anymore, I would say.
And are you also a proponent of applying the product thinking towards data sets? So not only AI products, analytics products?
I also have a bit of controversial opinions there. So maybe I'll share one. When we talk about data assets, right? The data is an asset. I like to say, remember, I like to think negatively. Your data is also liability. Yeah. I mean, having data is not only sometimes, having a lot of data is not only sometimes pointless because it doesn't go anywhere. It can be a problem because you do need to store it somewhere. You do need somebody to maintain this, somebody who keeps tabs of what happens there. So it could even be a problem. So the data, if it's not connected to a use case, you can always store it for a future use case. I think that's kind of the thinking in general, but you should really immediately try to connect it to some use case, to be honest. Otherwise, it's a liability, not an asset.
My opinion here would be that data as a product thinking helps here, because it actually departs from the data is the new oil, data is an asset.
Yeah, of course, yeah.
Because you have to choose for products. Not everything is a product. You have to choose what is a product, which data set is a product, and which data set is maybe something I want to delete because it's more liability.
100%, yeah. You have to look, and also this product thinking is another place which I want to mention. Is when I say data projects, I always think we should stop saying data project. We should just say data products all the time, because when you say project, it doesn't imply value delivery. The same word in itself doesn't imply value delivery. It means people work something, spend money. Yeah. So when you say a data product or a use case, whatever, that means, there should be some point to it. So in that sense, data products and product thinking and this whole vocabulary is absolutely necessary.
Great. Last word on the designing of data architectures and platforms. There's a whole movement towards self-service data engineering these days. So not only self-service, analytics, but really self-service data engineering and platform as a product or platform as a service, often as a product these days even. How do you think can you keep data architectures and platforms both user-friendly, compliant, and scalable at the same time? I mean, that's quite a hard thing to achieve.
There's some theoretical things we can go into, but I want to make it very, very simple what I think, because it connects to a previous point. If you have data engineers building something, they'll build something for other data engineers normally. So this is, I think, a lot of team topologies, data mesh ideas come into place, because if you have a data scientist doing some data engineering, they will always understand it's a very human thing, right? It's a very obvious thing. If you have a data scientist involved there by building, like you have somebody who really does some data engineering, there are people like this. You will build a data engineering platform which is actually usable. It's very easy. I have seen this all the time. You have the homogeneous group of people building anything. They will build it for themselves. It's very easy. It's a very easy mistake to make, because it's very productive. You put them, they know everything. They just work between themselves. They have the same language. Because if you don't have the data scientist, the data engineer is building the platform, they don't need to translate their daily work to this person, right? They kind of talk to each other in the same language. It's obvious what needs to be done.
And even worse with analysts, because analysts are even further away to data scientists and to data engineers.
So you sacrifice productivity short term by having a more heterogeneous team, right? You put the analyst inside of this data platform team, you put a data scientist there, maybe 20 to 80%, something like this. And this will be annoying shortly. People won't like this. The data scientists will also be confused, to be honest. But long term, you kind of make sure by little mutation in the genome here, you might get like a positive result down the line, because the right thing will be built. You have somebody there. So this is kind of a basic one advice I can give, which I have seen. Yeah.
Perfect. What do you think will be the impact of the whole generative AI on us as data leaders and on data strategy?
I try to be very measured in my words about hype in general. I try to, but in this case, I have to say it is a game changer. It is really. There's no other way to say this. I think the generative AI, especially the text form, it's every company has to consider this. Now, the bigger questions, there's just many use cases. You see them every day popping up. Most of them will be pointless, I guess. But any company will have a use case for generative AI. My bigger concerns here for enterprise customers as well, if I talk to them about this, is it's easy to say, and I'm a big fan of Microsoft in general, but still, like, it's a cloud vendor, right? So they provide you the nice OpenAI API, the nice Azure infrastructure to deploy these large language models. It's compliant. You have the ISO standards. You don't worry.
That sounds wonderful.
It is wonderful. It is. There's a problem, but that is a problem here. I'll come back to this. And you as an enterprise customer, you think, wow, they're going to take care of my data. I'll give them my knowledge graph, and they will give me nice generative internal upskilling bot, for example, that my internal people can talk to and understand the use cases.
So where's the catch?
The catch, I have seen this in other use cases, the catch is with the cloud providers. At some point, it might cost a lot. And at some point, you have the vendor lock-in. What's if you build everything there, what do you do once it becomes expensive, right? And it can become very expensive. If it really achieves its full potential, generative AI in the enterprise, it will become very expensive. Right now, it's not maybe. And then you kind of give the whole control there. So I do think it's better to take maybe a less productive approach, to focus on more open source language models and try to have your teams build their own open source systems instead of going immediately and building use cases there. Of course, you can do a POC with Azure and it will get you results, but then 5 years later, you're still stuck there and you might have a problem with pricing, or maybe data privacy laws change for the worse, or who knows.
Well, I would probably give a totally different advice than you to data leaders in corporate. I remember, and that was before generative AI times, that we several times looked and analyzed how much would it cost to shift from one cloud provider to the other. And typically it's okay. For a large company, it's usually several million euros, which is okay. Maybe tens of millions of euros, but you don't do that every year. And it's only when you really need to. And the last thing is, like, usually the other cloud provider where you're moving to gives you a lot of stuff and service and migration services for free. So I would be very much less worried about it. At the same time, taking any open source technology and trying to put it into enterprise grade standards that fulfills your regulatory requirement yourself is a mammoth kind of work. You probably spend more upfront than you would do for the migration later. So I think it's a balancing act. Sometimes it makes sense to create your own environments based on the open source services out there. But I would much rather recommend for the typical enterprise to simply adopt the open source version of your cloud provider or the commercial version of your cloud provider. And usually there's always a way out. Like, the other competitors are always very creative in finding ways of migration tools.
I have to agree with that point. Yeah, it's a balancing act, right? It's kind of the technology balancing act, open source, versus vendors. I agree. I mean, there's different ways. I think we'll see a lot of different models.
Perfect. Wow, we talked about so many topics, programming languages in the beginning. We talked a lot about data strategy and also operationalizing data strategy, and maybe a different angle towards data strategy, a fresh angle, I would even say. Let's wrap it up by looking a bit forward to the Data Masterclass Europe 2023. You will be part and present there. What will you talk about, and why are you looking forward to that event?
Well, I mean, I really try to bring my weird opinions about data strategy to a new audience, right? And I do think I can become this kind of abnormality, right? Because I'm a bit of a rebel in some of those ideas, and I want to see how people interact with them. And I try to be open also a lot about those data strategy ideas. My number one focus is, again, what I mentioned at the beginning. Static data strategy is the enemy. So this I will talk a lot about StratOps. How do we make sure we build data strategy in a way which is, we can do something with this? How do we measure those things? So that's one topic which I'm super excited to talk about, because I think it's still a bit of a niche point of view, right? So I want to discuss that. The other point is the data products. How do we integrate things, right? So I want to come from my CTO experience, my technology strategy experience, to really focus, and maybe with all those inspiring people, to have a look at their use cases and really imagine those things being integrated. The static endpoint just sitting there, it's not really exciting. So I can't wait to see how people start to think, well, that endpoint suddenly becomes like a nice widget here, right? So I really want to talk with data leaders to show how we can make sure that this happens at the end, right? How do you prioritize use cases? How do you have the technical feasibility? How do you measure them? How do you focus on this product thinking to get really closer to value? This is kind of my second big chunk. And it's really great. We have a great community. So I think it'll be a lot of interesting discussions.
Great. Thank you so much. It was an absolute pleasure and honor to have you here, Boyan. Thank you so much for the great discussion and for being on our Data Masterclass podcast.
Boric Data Masterclass, where great data journeys begin.